Hello everyone, my name is Shada Hakami. Me, Dr. Robert Hindley, and Dr. Philip Smith have been investigating emojis as sentiment indicators in Arabic texts. I am here to show you how we have done our experiment and what our conclusions are. Before that, let's have a brief overview of how humans communicate. Natural human communication involves both verbal and nonverbal channels. While the verbal cues are the words and sentences, the nonverbal cues are often the meta messages that instruct receivers on how to interpret verbal messages. In face to face communication, the nonverbal cues can be either by the use of the body, like eye contact, head nodding, and facial expressions, or by the use of the voice, like tone, stress, pause, rhythm, and vocal intonation. In text based communication, it's been argued that many of these nonverbal cues are missed, which potentially makes the communication ambiguous and inefficient. To address this issue, people often use many kinds of text based surrogates such as non standard punctuations, emoticons, and emoji. Emoticons are a sequence of ASCII characters that represent nonverbal behaviors such as these facial expressions here. On the other hand, emoji are a successor to emoticons with more sophisticated rendering, but they play a similar role. In practice, emoji are actual icons that appear on physical or virtual keyboards and can be used across various platforms, such as WhatsApp, Twitter, Facebook, Instagram, and others. These icons can represent facial expressions, body language, food, animals, places, and other natural objects like flowers and trees. Scholars have observed that including emoticons as well as emoji in text not only helps the receiver to infer some contextual information, but it also eases understanding of the expressed sentiment. Therefore, it's become necessary to integrate the analysis of textual content and emoji in order to properly undertake sentiment analysis. Sentiment analysis can be defined as a process that analyzes texts and builds an interpretation of the sentiment that it's intended to convey. Usually, it is one-dimensional measure from negative to positive, and it is quantized to just three values: negative, neutral, and positive. Some scholars considered the use of emoji to be understood as visible acts of meaning. Visible acts of meanings are analogically encoded symbols that are sensitive to a sender receiver relationship and they are fully integrated with accompanying words. Regarding sentiment analysis, some studies' findings suggest that the level of sentiment perceived from a text increases with the inclusion of facial emoji as well as non facial emoji. Going a step further, many studies have assumed emoji to be a reliable ground truth for the sentiment by constructing datasets for sentiment prediction and using a set of emoji to label their datasets automatically. Despite its intuitiveness, this assumption seems insufficient since it ignores that the emoji text sentiment correlation is context sensitive. Therefore, approaches relying on such an assumption might yield arbitrary and inaccurate sentiment and notation. So, the conventional approach of performing separate sentiment analysis of text and emoji and then combining the two to generate an overall value is inadequate. In this work, we seek to investigate the interpretation of the sentiment expressed in informal Arabic text with emoji. This is done by trying to answer from a broad perspective the following questions. First, when it's appropriate in sentiment analysis to use the conventional techniques for interpreting emoji. In other words, when are emoji a true sentiment indicators within the text? Second, what are the other unconventional cases of emoji in sentiment analysis and when do they apply? To answer these questions, we cannot merely consider a single emoji to be a representative or an indicator of one absolute sentiment unless we examine its sentiment state within that related context. In our methodology, Along with the sentiment analysis approach, we also used a technique from computer-mediated discourse analysis called coding and counting. This approach consists of three phases: observe, code, and count. In observation phase, we mainly focused on 5,402 texts from Twitter and each with at least one emoji. These were extracted from 7 different public Arabic datasets. We refer to this as emoji text dataset. Then we extracted all of the emoji from the emoji text dataset to form a collection of 496 unique emoji. We refer to this as emoji only dataset. Lastly, a third dataset was constructed, which consists of all the text in the emoji text dataset without emoji. We refer to this as plain text dataset. In coding phase, all of the text in the emoji text dataset were human annotated with either sentiment labels or emotional labels. For simplicity, we unified all the labels to be in the sentiment label form. For the emoji, each emoji in the emoji-only dataset was manually annotated. This was done independently by 3 native Arabic-speaking annotators, 2 females and 1 male. To test the reliability of this coding process, we used the inter-rater-Kappa agreement test that resulted in k equals 0.85, which is interpreted as a general high agreement among the 3 annotators. Also, we labeled each text in the plain text dataset with sentiment. An automatic sentiment annotation process was applied using the Python-based Arabic sentiment analysis model named Mazajak. In counting phase, to understand how each emoji is associated with each sentiment class, we undertook a frequency analysis of the text emoji association. This identifies the frequency with which each emoji is associated with human annotated text labeled as negative, neutral, and positive. We calculated 2 measures: the frequency, which is the absolute number of times that emoji occurred within text of that sentiment class, and the relative frequency, which is the proportion of the occurrence of that emoji that fall into that class. A similar process was repeated for each of the datasets. Finally, the number of emoji occurring in each text is counted. This referred to as the emoji load of that text. The frequency and relative frequency distribution of each emoji load for each of the key sentiment norms is then calculated to explore how sentiment varies with emoji load. This table, Table 1, shows the result for the 5 most common emojis in our data. Table 2 shows the results of counting the frequency of text in each sentiment class, both with and without emoji, besides the counting of the emoji only. The results show that for the negative and neutral classes, there was decrease in frequency of 3% when the emoji were included in the text. However, the number of texts classified as positive was increased by 6% when the emoji were included. In Table 3, we show the emoji load across all text and broken down by sentiment class. It's clear that the most usual usage is to include just one or sometimes 2 emoji in a text. The number of texts in the dataset with 3 or more emoji is much lower. It's also clear that the proportion of negative text is much lower when there are 3 or more emoji than when there are just 1 or 2. Similarly, the proportion of neutral or positive text increases. This may reflect that for negative text, it's sufficient to use one emoji to signal the negative sentiment in Arabic, whereas for positive sentiment, additional emoji are used to provide more emphasis. Based on the aforementioned quantitative observation, we analyzed the emoji textual behavior as sentiment indicators and noticed the following significant 4 cases: true sentiment indication, no sentiment indication, multi-sentiment indication, and ambiguous sentiment indication. In Figure 1, the analysis shows the relationship between particular emoji and the sentiment of the text. It's clear that some emoji are overwhelmingly negative indicators as the ones in the first row. Others are mostly positive indicators as the ones in the last row. Also, there are some are mixed in their sentiments as the ones in the middle row. With the kind of emoji that mostly represent particular sentiment, the indicated sentiment is usually explicit and clear for two reasons. First, the messages delivered within the text are themselves clear and unambiguous. These messages don't express irony, sarcasm, or other more complex linguistic phenomena. Moreover, most of the cases in our dataset where these emoji occur include sentiment words or phrases. We find that Arabic speakers, perhaps like others, usually use these emoji to directly articulate their feelings of sadness or anger, as in example 1, or love, cheerfulness, and satisfaction, as in example 2. The second reason is that these emoji often co-occur with other emoji from the same sentiment class, positive with positive and negative with negative. Thus, the combination of these emoji works together to strengthen the sentiment indication as in example 3. Note that in examples, the sentiment of the text only, the emoji only, and the text with emoji are identical. This means that when all the components of a text share the same sentiment class, they will end up reinforcing the effect, and so the result will clearly belong to that same sentiment class. Therefore, in this condition, emoji can be considered as direct true sentiment indicators for a tweet. For some of the emoji in our dataset, they don't appear to convey any sentiment indication, as in example 5. This is maybe because the sentiment of the text or the sentiment of other emoji in the same text dominates. However, often these emoji are used randomly with some other emoji in a way that it's not intended to convey any sentiment, or they may be used as decoration rather than to serve any real purpose, as the heartbroken emoji in example 7. Do you remember the row in the middle in figure 1 where we classify the emoji in that row as mixed sentiment? This is because these emoji can be considered as being true sentiment indicators, but with cases with two opposite sentiments. As positive indicators, these emoji have been found playing a significant role in cases similar to example 8, where the emoji indicates being funny, and example 9, where the emoji indicates being proud. In other cases, the same emoji as in examples 8 and 9 are found playing the opposite sentiment role, i.e., negative sentiment. This can be seen in example 11, where the emoji indicates being a mocker, and example 12, where the emoji indicates being arrogant. Beyond the cases mentioned above, there can also be an ambiguous sentiment indication for a text arising where an emoji exists, not only as a single standalone emoji, but also in combination with emoji with different sentiments. In example 14, human annotators agree on annotating this tweet with negative sentiment. However, when rereading the tweet, it could also be interpreted as positive tweet depending on context. This confusion in judging the tweet sentiment is because of the complexity of the sentiment of the text itself. Besides, the combination of the negative emoji, the positive emoji, and the multi-mixed sentiment emoji increases the complexity of deciding the sentiment of the tweet as a whole. Hence, none of the involved emoji can be considered the true sentiment indicator for this tweet. Finally, it's worth mentioning that the emoji sentiment indications stated above have been found within the data that we collected and sampled for this investigation. We are aware that the sentiment behavior of emoji is context sensitive. Therefore, One of the weaknesses of this work is that if the same investigative approach was applied on different datasets from different contexts, then these emoji may be found to behave differently as sentiment indicators. Another constraint of this work is the source of the text that was analyzed. Whilst Twitter provides a useful source for data, there may be differences between different social media platforms. Therefore, further research is required to investigate this. In the future, our work will expand upon the analysis presented here. We intended to compare the performance of this approach against some existing methods. Also, we would expect that similar phenomena to be found in other languages than Arabic. However, there are likely to be some differences with language and culture. Further work is necessary to confirm whether this is true or not. Thank you.